Okay, today's learning objective is to solve quadratic inequalities in one variable. This is a higher-only video. So this follows on pretty closely from last video where we talked about linear inequalities, and so it's quite important to have checked that out before. So if we're asked to solve the quadratic inequality of something, say x squared minus x plus, minus 30 is greater than equal to 0. How might we do that? So I think kind of the first thing, with seeing something like this, it's a bit hard to visualize. So it might be worthwhile if we plot the line y is equal to x squared minus x minus 30, we kind of might see a hint. And what we're really doing now, if we plot this line, right, we're looking for where y is greater than equal to 0. So we need kind of this to be equal to greater than 0. And if we're plotting this, we're looking for where y is greater than equal to 0. So you kind of just look out for that. So if we roughly sketch it, it's a positive parabola, and the y-intercept is minus 30, so it's going to be minus 30 here, and it's positive parabola, so we can kind of, it's safe enough to assume it looks something like this, for example, minus 30, x and y. And we need kind of the value of x squared minus x minus 30, which, remember, because now that we've plotted this line, is just the y value to be greater than or equal to 0. So we need it kind of, we need all the values of x which are over here, and we need all the values of x which are over here. And kind of to figure out what this value is, we just have to find the x-intercept, as we've kind of done before, right? So that's kind of all there is to it. So the first thing we have to do is kind of figure out what these x-intercepts are. We've done that before, so we just have to solve the quadratic of x squared minus x minus 30, which is equal to 0. Remember how we do this? We factorize, so we think of a number ab, which is equal to minus 30, and a plus b is equal to minus 1. So, if it's because it's minus 30, one of the numbers is positive, one of the negative numbers is negative, and the negative number is the larger one. So 30, we might think 3, 10, that doesn't work, because 10 minus 3 is just going to be, 3 minus 10 is going to be minus 7. Okay, let's divide 10 by 2, so 5, 6. 5, 6, yeah, that works, because 5 minus 6 is minus 1, so we can get, then we can say this is x minus 6 and x plus 5 is equal to 0. And then we say something like critical values, or we can say x-intercept if we really want to, I guess. But the kind of the good word here is critical values, which are these points right here. This is what we call the critical values, kind of where the x-intercepts in this case. Critical values, x is equal to 6 and x is equal to minus 5. So let's label it here, minus 5 and 6. And if we need kind of y to be greater than this, or kind of y and kind of by extension the inequality itself to be greater than this, we're looking for numbers on the right of 6 and on the left of minus 5. So we say, therefore, if we look at looking at the graph above, x is less than equal to minus 5, and x is greater than equal to 6. It's greater than equal to because we have a greater than equal to sign here, and that's kind of all there is to it. What's important is to follow this procedure of saying critical values instead of just just picking a random number. I'll do another one which is a bit harder, and we can if you pause the video, give this one a go first. So this is 5x squared plus 32x is less than 5x minus 15x squared plus 14. So pause the video and try to give this a go first. Okay, so what I'm going to do is rearrange this into a nicer form, a form that we're more used to, which is quadratic and less than equal to 0. So if we rearrange this, if we add 15x squared to both sides, we have 20x squared. If we add, if we take away 5x from both sides, we have 32x minus 5x. 32 minus 5 is 27 even. And then if we take away 14 from both sides, it's minus 14, which is less than 0. Now we have to solve this inequality. So what we have to do is also if we set this equal to 0 and solve. So instead of kind of setting to equal to and solving, what we do is we can just factorize this on the left first thing. So if we're splitting the middle term, we're looking for a number that multiplies to AB is equal to minus, so 14 times by 2 is 280, so minus 280, and then it adds to 27. So this is a bit harder to do this way. If you're really struggling to figure the numbers out, you can always just use the quadratic formula. But what kind of numbers here that might work? For example, if we're looking at it for a number like 27, so they're since they're both since one's kind of, there's a negative here, right? One's larger than one's positive, one's negative, and the larger one is positive, and they're reasonably far apart. 27 is a pretty big gap. So what I tend to do is kind of, if you look at something like what root 280 is, root 280 is 16 point something. So kind of, and we know one number is positive, one number is negative, and they're apart by 27, right? So if we're looking at maybe, so if we're looking at something like, maybe if we just go with something like 28 minus 10, so of course that's a bit too big of a gap, right? Now that's 48. So if we look at maybe 14 minus 20, does that work? No, that's what was that? Minus 34. So that's again a bit too big. So let's think of another number, maybe if we have something between 14 and 28. So something like, I don't know, maybe 20. So, oh no, that doesn't work because 20 is the 14th there. So let's see. So I mean, I could keep going thinking about this, but since I'm kind of got it this quickly, I know I can just get my quadratic formula out and probably solve it a lot quicker. So if I say kind of, if I get it out, because if you give this a go and it's taking a bit too long, your life will just be, you can save a lot of time in the exam if you just then move on to the quadratic formula. So quadratic formula, we have minus b minus 27 plus minus the square root of b squared, which is 27 squared, minus 4 times by 20 times by 20 times by minus 14 all over 2a, which is over 2 times 20. So we say something like critical values x is equal to, and then we have x is equal to, and if we just get our calculator out, we can do this, minus 27 plus square root. So I mean, it's easier if you just evaluate the square root first. So you get root of 27 squared minus 4 times 20 times minus 14, and that comes out to 43. So we have minus 27 plus minus 43 all over 40. And if we just evaluate both those cases, so x is equal to, then so 27 minus 27 plus 43 is 16, and divided by 40, that's 2 over 5. And the other case, we have minus 27 minus 43 divided by 40, that's minus 7 over 4. So these are our critical values now. Now we plot our graph to see kind of just to figure out which way we're looking for. So if we go down, so this is a positive cubic as we've seen, and then we have an intercept of minus 7 over 4, which is somewhere here, and 2 over 5, which is here. You can just plot that. Oh, okay, this just needs to be a sketch. Doesn't need to be very exact. 2 over 5 and minus 7 over 4. Y and x, and we have it's less than 0. So we're looking for numbers kind of below the y-axis. So we're looking for numbers in between here. So it's this strip that we're really interested in. So in this case, we know x is going to have to be less than 2 over 5, but greater than minus 7 over 4. And it's not greater than equal to, because we had this sign here. It's a less than sign, not less than or equal to. So we have, it's greater than minus 2 over 5, but x is less than, greater than minus 7 over 4, but less than 2 over 5. And that's kind of our answer. So in each step, what you do is kind of you rearrange to get quadratic in this form. Solve the quadratic when you kind of set it to equal to 0, and make sure you label this as critical values. Don't say x equals to, label this as critical values, x as this. Or else, the examiner might think you said, oh, x is equal to this, but I've said critical values, and these are the critical values of x. So, and then draw a graph like this. So if it's less than, then we're looking for something in between here. But if it was greater than, we'd have to have kind of these ones. So we just have to say x is greater than 2/5, and x is less than -1/4. So just watch out for that. Also, if you ever come across a negative, so if in the question it's minus x squared, or the coefficient of x squared is negative, remember you'd have a parabola that's flipped. So make sure you do draw it out so you know what what happens, because in this case, if it's greater than 0, right, then you're looking at a number in between two numbers. Whereas before, if it's greater than in the positive parabola, you're looking at it's going to be larger than one number and less than another. It's not going to be you're having two of these things, but whereas if it's a negative parabola, you'd only have in between two numbers, if you get what I'm trying to say here. So that's what happens in that case. So just watch out with negative parabolas. But yeah, hopefully that all made sense, and I'll see you guys in the next video.